Welcome back to my channel Physics Fun Do Classes. Today's lesson is uniformly accelerated motion. Now we first understand what is acceleration. What is acceleration? The rate of increase of velocity is known as the acceleration. Now numerically we have the acceleration is equals to v2 minus v1 by t2 minus t1, where v1 is the initial velocity of the particle and v2 is the final velocity of the particle. Now let's move to velocity. What is average velocity? V average is equals to change in velocity by total time taken. We can write it v2 vector minus v1 vector if we consider that v by t2 minus t1, or v average may be written as delta v by delta t. Now if we draw a graph, velocity time graph, let us consider along the x-axis this is time, and along the y-axis is the velocity. It is a graph. Now let us consider 2 points, that is A, that is B. Here it is T1, here it is T2, that is V1, it is V2. So coordinates of the A point is V1, T1, and that of the B point is V2, T2. Now joining this, we'll have a right angle triangle. This angle is theta. Now the average velocity V average is equals to tan theta. Is equals to tan theta means, name it C, that is BC by AC. That is equals to BC means V2 minus V1 by AC means T2 minus T1. Now let's move to instantaneous velocity. What is instantaneous velocity? Instantaneous means a particular time, a particular instant. So here the limiting value of average velocity, that is V avg, that is equals to limit of delta t tends to 0, delta v by delta t equals to dv by dt. It is the instantaneous velocity of a particle. It is the instantaneous velocity of a particle. The instantaneous velocity we have v instantaneous, that is equals to dv by dt. Here v instantaneous equals to, we can write it as it is ds by dt dv by ds. Now ds by dt is v, that is v dv by ds, v instantaneous. It can be transformed to that form also. Now we prove kinematic equation for a uniformly accelerated particle along a straight line, along a straight line. What are the equations? First we prove v equals to u plus at, where v is the final velocity, u is the initial velocity, a is the uniform acceleration, and t is the time. Now here we have the uniform acceleration is equals to change or increase in velocity by time. Increase in velocity is v minus u by rate of change, that is t. Now here acceleration is a, so a is equals to v minus u by t. So here v minus u is equals to at and v equals to u plus at. Now let's move to the next equation. Move to the next equation, B equation. S equals to ut plus half of a t square. Here we have to consider the average velocity. V average is the average velocity of the particle. Average velocity is, initial velocity is u and the final velocity is v. So u plus v by 2. Now the distance covered, s equals to distance covered, is equals to v average into time taken. Now v average is equals to u plus v by 2 into t. Now we know that v equals to u plus at. Putting it, u plus at by 2 into t, that is equals to 2u plus at by 2 into t. Right? Now writing it here. So s is equals to 2u plus at by 2 into t, term by term, divide 2u by 2 plus 80 by 2 into t, that is equals to u plus half 80 into t, that is equals to ut plus half a t square. Equation proved. Now let's move to the fourth equation. D. Third, C. This C. C. V square equals to u square plus 2as. Again, V average is equals to u plus v by 2. Simple. U plus v by 2. Now, S equals to V average into time. Now, V average is u plus v by 2 into time. Time can be replaced by that equation. V equals to u plus 80, that is t equals to v minus u by a. So that is equals to v plus u by 2 into v minus u by a, that is equals to v square minus u square by 2a. S equals to get. S equals to get. Now from this, multiply 2a with s. 2as is equals to v square minus u square. So here we have v square minus u square equals to 2as, that is v square is equals to u square plus 2as. That is the equation we have to prove. The fourth equation, D. S of tth equals to u plus half a to t minus 1. What is tth? Tth is a particle time. A particle travels a distance. A particle travel a distance at tth time is s tth is equals to u plus half a to t minus 1. Now how to proceed? We know the equation s is equals to ut plus half of a t square. Now before the 1 second before, we have s dashed is equals to u of t minus 1 plus half a t minus 1 whole square. Now s of tth is equals to s minus s dashed, that is equals to ut plus half a t square minus u into t minus 1 minus half a t minus 1 whole square, that is equals to. Now ut taking together minus ut minus minus plus u plus half a common from this and this. Within the bracket we have t square minus t minus 1 means t square plus 2t minus 1. A minus b a square minus 2ab plus b square. So t minus 1 whole square, t square minus 2t plus 1. As there is minus, so plus minus minus, minus 1 is plus, and plus minus again minus. Now t square will be cancelled out, here ut will be cancelled out. We have u plus half a 2t minus 1. This is s tth. S tth. Now we have to prove x is equals to x0 plus ut plus half of a t square. Now how to prove it? V average is equals to displacement x minus x0 by time taken t. Now again we have v average is equals to u plus v by 2. x0 is the initial position and x is the final position. Now equating this, x minus x0 by t is equals to u plus v by 2, that is equals to u plus at, replacing v by u plus at by 2. Now we have x minus x0 by t, that is equals to 2u plus at by 2, that is x minus x0 by t is equals to 2u by u, means u, and at by 2 half of at. So we have x minus x0 is equals to t multiplied ut plus half of a t square, that is x equals to x0 plus ut plus half of a t square. That is the equation. Now we have to prove v square equals to u square plus 2a into x minus x0. Now v average is equals to x minus x0 by t, that is equals to u plus v by 2. Now here x minus x0 is equals to u plus v by 2 into t. We know that v equals to u plus at, so t equals to v minus u by a. Now x minus x0 is equals to v plus u by 2 into v minus u by a, that is x minus x0 is equals to v square minus u square by 2a. Now we have v square minus u square equals to 2a into x minus x0. So here v square equals to u square plus 2a into x minus x0. That is the equation. Now we will study about the displacement time graph. Displacement time graph. Displacement time graph. Here we'll draw all of the graphs of displacement time. The x-axis, y-axis, we take the time along the x-axis. This is the origin O, and this is the displacement. Now here we draw this, now draw this, now draw this, now draw this, now draw it, now draw it. Here we have drawn the 6 graphs. Let us marking them. This is 1, 2, 3, 4, 5 and 6. For the first graph, we see that the displacement is unchanged, but the time is changing. Displacement is unchanged, but time is changing. Time is changing. So the displacement is constant. Displacement S is constant. Now rate of change of displacement ds by dt, that is equals to d dt of constant. D dt of constant is 0. So we have the velocity of that particle obeying that equation is 0. Now we can depict it in the another way. If the displacement time graph is parallel to the time axis, then the velocity of that particle is 0. Now move to the second graph. For the second graph, we see that is the displacement and it is the time. It is the time. That is the equation. We know that the tan theta is equals to V, that is equals to ds by dt. We already know that. Now, what is theta? Theta is the slope. If we consider that point A, now B, now C, we see that the angle with the time axis is continuously decreasing. So the velocity of that particle is continuously decreasing. Now move to the third graph. This is displacement and it is time. For that graph, it is a uniform velocity, ds by dt. If we divide it in the equal time of interval, it will cross the equal displacement. So v equals to ds by dt is the uniform velocity. This is the uniform velocity of the particle. Now let us move to the fourth graph. Here we see that there is a displacement and that is time. That is continuously increasing. If we consider A, B and C point, we see that the tangents making the angle with the time axis is continuously increasing. That is, the slope is increasing. Tan theta is equals to V equals to ds by dt. As the slope is increasing, the velocity of the particle is also increasing. Now move to the fifth graph. This is the time axis and this is displacement. Okay. Now it is a straight line perpendicular to the time axis, where we see that the time is 0. If the time is 0, then the velocity will become infinite. Velocity become infinite. Now move to the sixth graph. This is displacement. This is time. The graph is like that. Here we see that this is a uniform velocity motion, but its angle is obtuse. So if the angle is obtuse, then there is the negative uniform velocity. That is negative uniform velocity. Draw the velocity time graphs. That is velocity time graphs. This is O, X and Y. So 1, this is, this is, and this is. Right? This is the number 1, 2, 3, 4, and 5. For the first graph, number 1 graph, what we have seen that the graph is a straight line parallel to the time axis. Parallel to the time axis. Velocity is not changing. Velocity is constant. Velocity is constant. Now, what will be the acceleration of that particle? Acceleration is equals to dv by dt. As the velocity is constant, so d of constant by dt is equals to 0. So there is no acceleration of that particle. Now let's move to the fourth equation before we move to the second graph. For the fourth graph, we see that this is slope, this is the acceleration is equals to dv by dt. The change in velocity with respect to the change in the time interval is equal in that case. So acceleration is here the uniform acceleration, but initial velocity is 0. But in the second equation is the uniform acceleration but present of initial velocity. Present of initial velocity. Present of initial velocity. Now let's move to the third graph. For the third graph, we see that this is the velocity, this is time. The slope of that graph is continuously decreasing. So slope is acceleration. A equals to tan theta is equals to dv by dt. It is a non-uniform acceleration and its acceleration is continuously decreasing. But for the fifth equation, but for the fifth graph, we see that its slope is continuously increasing. So its acceleration is continuously increasing. Now, for the kinetic equation for a uniform motion, we have to solve it or prove it graphically. Let us draw the velocity time graph. This is the velocity time graph. Velocity time graph. The velocity time equation, marked it by AB, and draw the perpendicular over the x-axis BC, and from A point we draw the perpendicular AD. Now here OA is the initial velocity, that is u, also DC. Now OC is the time interval, so OC is equals to AD. Now this is the uniformly accelerated motion. We have to find tan theta for that equation. Tan theta is equals to, from that graph we have BD by AD. Now BD can be written as BC minus DC by AD. Now what is BC? BC is the final velocity, that is v. Now putting it, BC is v minus DC is u by AD is t, and tan theta will give us the acceleration, uniform acceleration A. So we have v minus u is equals to AT, that is v equals to u plus AT, u plus AT. Now move to the second equation. We have to find the displacement S. Displacement S is equals to area covered by the graph AB. And now for the area covered, we have the area of the rectangle AOCD plus area of the right angle triangle ADB, that is equals to area of AOCD is AO into OC plus area of ADB is half base into height. Now that is equals to AO means U and OC means T plus half AD. AD means T and BD means AT. So that is equals to UT plus half AT square is equals to that. Now we have to prove the third equation. V square is U square plus 2AS. Now here AS is the displacement. AS is equals to area of the trapezium. Area of trapezium AOCB, that is equals to half into sum of the parallel sides AO plus BC into perpendicular distance, that is AB. Now that is equals to half into AO means U and BC means V and AD equals to time. So we can write V minus U by A. We have half V square minus U square by A. So here A is equals to V square minus U square by 2A. So V square minus U square equals to 2AS, that is V square equals to U square plus 2AS. Now here we have to prove ST equals to U plus half A to T minus 1. So ST is equals to area of the trapezium B dash C dash CB, that is equals to half sum of the parallel sides B dash C dash and BC into D dash D, that is the perpendicular distance D dash D. Here B dash C dash we can write half into U plus A into T minus 1 plus BC means U plus A T. And where is D dash D? D dash D is T minus minus plus, that will be cancelled out. Now here half into, we can write it U plus U, that is 2U plus AT minus A plus AT, that is equals to half into 2U plus 2AT minus A, that is equals to half into 2U, half into 2U plus half into a common 2t minus 1. That is, st is equals to 2 to cancel out, u plus half a 2t minus 1. That is the equation. That is the full lesson for today, and we will discuss the numericals on that topics in the next class. So for the day, goodbye. Please share, like and subscribe to enhance our support.